So just to remind you, so step one is all about finding that first or easiest common multiple. So in this example here, it is maybe easiest to get to the first common multiple because these are very low denominators, 5, 10, 15, 20, 4, 8, 12, 16, 20. So it's easy to find that first common multiple. But sometimes when you have big denominators like 13 and 22 or something like that, instead of doing multiple streams, it might be easier for you just to do, it's called the easiest common denominator. And you can find the easiest common denominator simply by multiplying the two numbers together. And so you would apply the other factor to the first fraction and the other factor to the second fraction to get that commonality in the denominators. We're going to work through some examples like that together. So step two, you simply, after you get the denominators looking like each other in shape and in form, then you can add or subtract the numerators with ease. Lastly, we're going to put the sum or difference, the answer, into one fraction, and then I'm going to teach you how to take this fraction and either reduce it or simplify it, maybe change it into a mixed number so that it has more of a standard form when you're complete with it, okay? So we'll talk more about mixed numbers as we go forward over the next couple days, but this is how we connect between mixed numbers and improper fractions. We call it improper because the numerator is larger than the denominator. And when that happens, it's showing an amount that's greater than 1, right? So it's a little more impactful when we see that value greater than 1 in a mixed number format. It looks more powerful to see a whole number with just the leftovers or remainder part of the fraction next to it. So how do we flip between the two? Well, let me start first by, once I get an improper fraction, how do I make it look like a mixed number? And the answer is simply divide. 17 divided by 5. And when we set that up, we'll see how many times does 17 go into 5? Well, it goes 3 full times, and there will be 2 of the fifths left over. So think about that. What is 3 times 5? It's 15, right? And if we add 2 more, that's 17. So we can flip between the mixed number and the improper fraction just by using some of these tricks and techniques. So 17 divided by 5 will get us 3 2/5. And then the way we convert it back to improper fraction, if you wanted, we'll talk about more of this later this week, is you multiply the bottom 2 and add that numerator. That's called, I call it the around the world trick. So we're going to be working with a couple more examples today. Let me pull up one of the worksheets. Now, if you don't have your worksheet with you, it's totally fine. You can just write down the fraction addition problems and fraction subtraction problems on a piece of loose leaf, okay? Let me see if I can find those on my desktop. Mrs. Moore needs just another second here, guys. I think they're in my downloads. There we go. I'm going to open those up. And now I'm going to share these with you. I'm going to work on the addition one first, okay? So this is the first worksheet. And I'm going to do the first 6 with you on the adding one, and then the first 6 with you on the subtracting one. All right? What would be helpful is for you to have your multiplication charts so you can help yourself with the least common multiple here. I'm going to also show you how to do the easiest common multiple too. That way you can decide based on what problem's in front of you, what would your most successful approach be, okay? So for this first fraction, remember step 1 is to get common denominators. And the denominator is that term that's in the bottom, right? So I like to just circle them to call attention to which values am I finding the common multiple of. So 2's and 5's, those are easy. We could probably even do them in our heads. You can look down your multiplication chart. When is the first time a multiple of 2 is also a multiple of 5? Anyone know? Michael, when is it?
4 is the closest.
Oh, I can't hear you guys today. Let me take off these earpods. I can hear me, but I can't. I know you can hear me, but I can't hear you. Let me see if I can kill these. Turn Bluetooth off. All right. So what was the answer that you said there? What's the first time that 2 and 5 meet?
I'm not sure
10,
about the
right?
fraction yet, but I know 4 is the best that 2 can do.
All right, so I'm going to write it down here for you to see out loud. 2, 4, 6, 8, 10, just like we did during class, right? 5, 10, 15, and so on. And we can see 10 is the first place that they meet, right? So I'm going to use 10 as my common denominator for adding these fractions. So let me just set up the two fractions with the new denominator, all right? And then I'm going to use that equivalent fraction technique of, well, how do I convert a 2 into a 10? What factor lets me convert 2 into 10? It's 5, right? 2 times 5 would be 10. So I use that same factor on the numerator of that fraction. So what would 1 times 5 be? It'd be 5, right? For the next fraction, I'm going to be using a different factor because it has a different denominator. So how do I get from 5 to 10? That's with the factor of 2, right? So I'm going to use the factor of 2 on this numerator. What's 1 times 2? That's 2. So now that they look alike and they're both in terms of tens, I can add them together. 5 tenths and 2 more tenths together make 7 tenths. And that is going to be the final answer for today on this type of problem, okay? It's a proper fraction. The numerator is smaller than the denominator. The numerator and denominator do not have any factors in common, so I can't reduce or simplify it anymore. It's done. How about you look at number 2. When is the first time 9 and 12 have a common denominator or a common multiple? So think of your 9s, 9, 18, 27. Keep doing that until you think of where does it meet with the 12s. Can you find a spot? Maybe type it in the chat box since I'm having a hard time hearing you guys today. Oh, maybe now it will work. I'm trying my mute function here. When's the first time 9s and 12s meet? I'm going to start writing them out. 9, 18, 27, 36, 45. Let's see if I got any matches yet. 12, 24, 36. Oh, hey, look, 36. So we have to convert 9ths into 36ths and 12ths into 36. Oops. How do I get from 9 to 36? So this whole fraction has to be changed, has to be adjusted to have the same denominator, right? So what factor will help me get there? What factor do I need to get from 9 to 36? Show me with your fingers. What factor do I need? That's right, Sam. I need a 4, right? So I'm going to multiply both the top and the bottom by 4, right? 9 times 4, 36. Good. 2 times 4, 8. So look at that next fraction. How do I get from 12 to 36? What factor do I need? Show me with your fingers. 3. I need a 3, right? Because 12 times 3 is 36. So use that same factor on his numerator. 4 times 3 is 12. I don't know why I think of this silly metaphor, but hang with me here. So each of these fractions are different in the way that they look, right? But I think of them as getting dressed in their uniforms for school. They're all going to look alike. Even though their values are different, we need to make them look alike so that I can combine them. So I kind of am, in my mind, I made up this silly idea that when I'm doing common denominators, I'm getting my fractions in uniform. I'm getting them ready to be in a group together. Does that sound like something you can connect with a little bit, maybe? All right, look at this next one, number 3, and tell me what their least common multiple is. Tell me what you think. So between 10s and 6s. And we can start writing out the multiples if you want. 10, 20, 30, 40, right? You can start using that technique, right? Michael, when's the first time that they meet?
30.
At 30, that's right. So if I'm writing out the multiples, you'll see that the first time they meet is 30, okay? And so we can use 30. We can use 30. That would change this numerator. That'd be a factor of 3. So 1 times 3, 3. And that would change this fraction by a factor of 5. So what would 5 times 5 be? 25. We could do that. That's one way to handle it. We would get 28 over 30, right? We could do that. There's another way that you could do it using the easiest common multiple. I'm going to show you what that means. Because we'll get the same answer. The easiest common multiple would be simply to take 10 and 6 and multiply them together and use 60 as their denominator. So how would I get from 10 to 60? I would multiply times 6. How would I get from 6 to 60? I would multiply times 10. And you're going to say, but Mrs. Moore, those don't look alike. Those don't look the same. They don't, because I didn't reduce and simplify them. So the way that I reduce and simplify is I find common factors to remove from both the numerator and denominator at the same time. So I'm going to do and demonstrate that one with number 2. I'm going to demonstrate reducing. So what factor could come out of both 12 and 36? Oh, we didn't finish adding this up, did we? Mrs. Moore is not herself today. What factor could come up out of 20 and 36? They both share 2, that's for sure. Do they share anything bigger? I think they both share 4, right? So if I divided or simplified both of these numbers by a factor of 4, has to be the same factor, I would end up with 5/9. And 5/9 is the simplified answer. It's equal in value to 2036, but it's the simplified lowest term version of itself, okay? And don't be worried if that skill doesn't come really easily today on day 1. This is something that you're going to get better with as the week goes, all right? So if today you can get 2036, be proud of yourself. Be proud of yourself for being able to convert fractions properly, combine them properly. Be proud of yourself for that. If the reducing part has to come later in the week, I'm totally fine with that. I'm just modeling it a little bit for you right now. So here for number 3, what could come out of both a 28 and a 30? A 2, for sure, right? They're both even numbers. So if I divide off a 2 on both the numerator and denominator, I'm left with 14 over 15. And 14 over 15 is the final reduced form of that fraction. You might just have to take my word on it, but you can divide both these fractions by 4, and guess what you'll get? 14/15. Why? Because they're equivalent, right? And it's okay if we started with different denominators. As long as we reduce them to their purest form, they're going to end up being the same value, okay? What do you think about number 4? What would their common denominator be? What should we use? Between 11 and 4. Feel free to unmute.
44.
Thank you. Yes, it's 44. So as time goes, everybody, you see all these arrows and all this extra stuff that's helping you understand. You might not need to do that anymore. You might be able to, in your mind, go, okay, what factor do I need for this fraction? And then do it up in your head. But if you still want to draw the arrows, it's totally up to you. What factor, Esther, would I need to get from 11 to 44? What factor would I need to apply to this fraction?
4.
Got it. So 1 times 4 is 4. So notice how I eliminated all those extra arrows and all that crazy business now that we know what we're doing. All right, someone else. What factor do I need to apply to this fraction in order to make it look like 44ths? Come on, Cece, Isabella, Tegan. What factor do I need to put on this fraction to change 4s to 44ths? What factor would make that happen?
11.
That's right, 11. So what would 2 times 11 be? 22.
22.
Yep. So now I can add them up. 4 and 22 together make 26. We keep the denominator. Now you're probably looking at those and saying, oh, those are both even numbers. They can be reduced by a factor of 2, right? We can reduce them by a common factor of 2, which would leave us with 13 over 22. 13's prime, so we're done. As soon as you have a prime number in either the numerator or denominator, you're done. Is this feeling a little bit more fluid? Let's try a couple subtractions. So same process, convert to the common denominator, and then instead of adding, what are we gonna do on the next page? We're gonna subtract, okay? So let me pull up that one instead. You're doing a really good job. All right, so here we go, subtracting, unlike fractions. Common denominator, hey, look at, number 1 already has common denominators, right? So there's nothing to adjust, there's nothing to change. What would 2/3 minus 1/3 be? 1, keep the denominator, third. That one's done. Yay, that one was easy. What's the common denominator between 11 and 6? How about 66? Does that sound okay? And remember, we're subtracting this time. How would I get from 11 to 66? How would I get there? What factor would make me get there? Aubrey, Tegan, anybody?
6.
6, that's right. So what would 6 times 4 be? 24, right? Now, how would I get from 6 to 66? What factor? How would I get from 6 to 66?
11.
11. So 2 times 11 is 22, right? Good. So then my last step would be to subtract, right? What would 24/66 minus 22/66 be? Just 2/66. Can I reduce these at all? What do you think? Do they have a common factor? They do, right? They're both even, so I can divide them both by 2 and I would get 1 over 33. All right. Feeling a little better? This side, we're rolling on this side, aren't we? Because we understand what common multiples are. And we understand that we have to apply different factors to different fractions to make them look like each other, right? So what's the common denominator between 4 and 3? What's the first time those multiple streams hit? Anyone can unmute and answer. I can't see all of you on the screen at the same time. So if you're, feel free to unmute. It's just us.
12?
Yep, 12 is it. So I'm going to write and set up my fraction, my new converted fractions. I'm going to set them up with a new denominator of 12 and then ask myself, how do I get there? 4 times what makes 12? 3, right? So 3 times 3, 9. What times 3 makes 12? 4. So 2 times 4, 8. Good, so what's the difference? 9 twelfths, 8 twelfths, 1 12th. And that can't be reduced anymore, right? That one's all set. I do think subtracting fractions is a little bit easier because it makes the number smaller because you're like eliminating value, right? So when the numbers get smaller, it's often easier to reduce. It's usually a very simple factor to simplify it with. What about between 3 and 6? What's the first factor that they meet at? What's the first multiple? I think just 6, right? 3, 6. 6 meets at 6. So let's use 6. And this one's all done for us. So we don't need to change him in any way, right? 3/6 is already in 6th. We just need to convert this guy. What factor do I need to convert thirds into sixths? A factor of 2, right? 3 times 2 is 6. 2 times 2 is 4. This part's a breeze. 4 minus 3 equals 1. Keep the denominator, 6. All right, kiddos. I think we're off to a great start here, but before we sign off, how about we just look at each problem and we decide on a common denominator, and then you can do all the converting on your own. Does that sound like a plan? Okay, I'm going to stay on the subtraction page first. All right, so these are all the remaining problems on the subtraction side. Now here's my multiples that I'm trying to meet at a common spot. Where would 12s and 5s first hit? Maybe use your multiplication charts to help you, or start saying the multiples in your head of the bigger number first. When do you get to the first spot where it meets that multiple stream of 5s?
60?
60. So this is what I want you to do, is just set up your new fraction zone and then come back later and solve it. Where's the first spot 10s and 8s hit? The easiest spot would be 80, but the first spot they hit is actually 40, okay? How about 11 and 3? Where's the first spot they hit?
33?
33. You're onto it. This is the hardest part, is figuring out what denominator to use. The rest, I think you guys are great at. All right, how about number 8 here? What's the first common multiple they share? 5 and 6.
30.
Yep. And this guy, whenever there's an 11 involved, it's really super simple. 44.
44.
Yep. And then 10, let's see, 12 and 3. Well, 3 hits the 12. 3 hits 12, right? So 12 is going to be it. And then 5 and 4 is going to be 20s. We did that one earlier. And how about 10 and 4?
40.
40 would be the easiest, and you can use 40. There's one that comes first, though. One that comes before that we can use too.
20.
That's 20, yeah. So we're all set with our denominators now. Now you're going to, each fraction at a time, use a common factor and adjust its the way that it looks, like put its uniform on, so that you can add or subtract it. Do you want to go do the same thing with the addition page? Yeah? Okay. I'm going to clear this out. Let me get the addition page here. All right, let me scoot down a little bit here.
More.
Yeah?
Before we started, I did some for the adding one. I didn't do subtracting, but I did some of the problems by myself.
Mm-hmm.
But I didn't. I just put like the real answer, not the equation part.
Well, you probably have the equation part on a loose leaf somewhere, because there isn't a way that you could add them without converting them. It's just, I would like to see how it changed into its uniform before I see the answer. That way, if your answer's wrong, then I have at least a path to go back and look at maybe which step that went wrong, okay? So I do want to see the equation part, just like I was practicing with you. You don't have to do all the arrows and all that business, but I do need to see, how this fraction changed into his uniform, okay? So what is the first common factor between
45.
45, that's right. How about 9 and 11?
99.
99. How about 7 and 5?
35.
Wow, you guys are getting so fast at this.
6. 6.
So you're changing
14.
all these fractions into their uniforms.
28.
28.
Whew, I can't even
40.
write to keep up this fast.
40.
40 is the easiest.
5.
There's one before it.
5.
They don't meet at 5. It's 20, yeah, set 20. But you could use 40 if you want. You're just gonna have to simplify more on the back side. How about 12?
108.
They don't meet before then?
Um,
What's the factors or the multiples of 12? 12, 24, 36, 48.
36.
And look at 9 goes 9, 18, 27, 36. Let's use 36. That's a lot easier than 108. You can use 108 if you want to, whoever said that, but I think the other one will be easier. Okay, last two.
66.
Sure, 66 for this one.
35.
35.
35 for this one. Well done. All right, you know what to do now, right? We're all converted. Now you're gonna put the uniforms on each fraction and then add them on this side or subtract them on this side. Start to simplify if you're able, but don't worry too much about it. The focus skill today is converting the fractions to have their uniforms on, common denominators, and doing what operations involve. Michael?
So the problems that we did together are on a loose leaf sheet, not the paper. So do you want a picture of them too?
Just show me the remaining problems, okay? I think it's 5 through 12-ish or 5 through 14, whatever, on both sides, okay? Wow, this was a lot of brain work today. And you know what? This is such a hard section. We're gonna do more with this same idea tomorrow, okay? I might pick a couple bigger fractions so that we can practice more with simplifying and converting to mixed number, improper fraction, that kind of thing tomorrow. But for today's work, you did a really, really nice job. Thank you.
Miss Moore,
Mm-hmm.
do we turn in these worksheet